Okay, class, this is our next component in Whitlock and Schluter Chapter 11. We're doing hypothesis testing. So, this is a great example from Whitlock and Schluter, and the usual number that we're given for human body temperature is 98.6 degrees Fahrenheit. Is this the true human mean temperature? Well, we have a sample of 25 randomly chosen healthy people, and we've got a mean of 98.524 with sample standard deviation 0.678. Okay? We're going to conduct a hypothesis test now to see if the data provide evidence that that number is too high. Okay, now again, a hypothesis test, we have 4 steps that we use to go through the test. Number 1, set up your null and alternative hypothesis. Number 2, calculate your test statistic. Number 3, compute the p-value. And then number 4, make a decision based upon that. So, here we go. Checking assumptions. Body temperature is normally distributed, so we have a normal parent and we have a random sample. So, boom, we've got the assumption in. Null hypothesis. Mean is equal to 98.6 versus the alternative, mean is not equal to 98.6. Prior to data collection, we had no idea whether the sample would go high or low, so we just test anything other than what the historical claim is. Okay, the 98.524 is my sample mean. Standard error, I have that put out as well, 0.678 over rad 25 over the sample size. Okay, so that gives me 0.136. Now, time for a curve. Okay, with the hypothesis test, there's a fundamental difference in the way we sketch the curve from the confidence interval, because the null this is called the null distribution, and in particular, it has a mean of 98.6. Okay, and the t statistic, we're going to use statistic minus parameter over standard error. So this here is the level of the sample mean. We have a t level as well. We get 98.524, so we'll go ahead and put that down here. 98.52. And what's the t statistic turn out to be? Well, when I plug in here sample mean, population mean, and standard error, I get 0.56. So on the t level, 0 is in the middle, and I've got a 0.56 is here. Now the p-value would be the probability that I'm at or below this 0.56 value. Okay, so if it was a normal distribution, I could actually calculate the area under the curve, but since it's a t, I don't have the ability to do that on the table. What I can do here is go right, I don't have the ability, to the table and at least take a look. So our degrees of freedom is 24 since n equals 25, so let's go ahead and make a remark about that. Degrees of freedom is 25 minus 1, which is 24, and we're going to test this thing. It doesn't say, so we're going to use alpha is 0.05. Use that unless otherwise specified in a problem. So we're here at 24, and we have a 0.05. It's a two-tailed test. As we said, we're using a not equal to in the null hypothesis. That gives us a 2.06. So we go in, and 2.06 is the value that I come up with. So 2.06 would be, I'm going to use red. That would be the number out here that would cut me off at 5%, and I'm going to put the 2 on there just to denote that that's a negative 2.06. The negative sign was dropped off here. 2.06, and that is also 5%, but cut in half. Okay, so the left side is the rejection region, the middle is the acceptance region. We're in the rejection region. Therefore, we conclude do not reject the null hypothesis, which I have stated down here. So this historical number for body temperature is consistent with our data. Okay, now I have the command to run that using R. It's t.test, just as the confidence interval was. Take note, you've got to put in the mean that you want to test against, otherwise the p-value calculation will be off. So this is the t-stat we got with the degrees of freedom we got. Here's a p-value we didn't have access to, 0.5802. So we can put that in to add some information here. So 0.58 is this left value plus what it would be on the right. If I were to use R, then I could find, using this command here, PT, that's T for students' T distribution, P for cumulative probability, as we saw before, plugging in the T statistic with the degrees of freedom. 0.29, that's the left-tailed probability. If I multiplied it by 2, I would get the 0.58 that we get for the p-value in the R output running the direct command. Okay, now I'd like to make a couple of remarks and then do one more example. So we're assuming that the data are normal, okay, or that we have a large enough sample. Now, a nice way to calculate the p-value is to don't worry about negatives and positives, just take the absolute value of the statistic, and that's the p-value. Double it if you are two-tailed. Okay, now for the decision rule, this is always the decision rule. If we're below alpha on the p-value, we reject. If not, you accept the null. But using the t-statistic alone, if you take the absolute value, then we simply check if it's greater. What does that mean? Well, take a look. In our case, we're using this 2.06. We had to go, oh, okay, it's negative because we're on the left. We got a negative 0.56 from our statistic. But if we just take the absolute value of that negative 0.56 and compare it with the 2.06, then if it's bigger, that means it's going to be farther out into the rejection region. We reject. If it's smaller, we accept. This gives us a simple little rule if we'll use the absolute value. Okay, now one more example. Let's go back to the coal car, and this will be the most explicit coming to the manufacturer's claim. They're claiming 75 tons, so we test against 75 tons. The alternative, below 75 tons. Did we get ripped off? In this case, we are simply presuming the manufacturer is not going to be giving out more coal, and so we rule that possibility out. So the curve sketch is going to go like this. Okay, mean of 75, and we got 74.5. P-value is going to be this region here, whatever it is. We just need to find out. So this is at the level of the mean, and we're interested in the level of the t statistic. We know the center is at 0. So let's go ahead and do the t statistic is going to be 74.5 minus 75 divided by standard error, which was 0.13 from last time. And so that is going to give us a minus 3.95. So using this minus 3.95, I go here minus 3.95. That number may look familiar. So we're going to look that up on the t table. Let's see, minus 3.95. And we can't, let's see, we're in this 40, and at the t table we can't actually look it up. What we can do is see it's between these two numbers, which is going to tell me my p-value is in this range right here between 0.001 and 0.0001. That's the best that we can do. Okay, so let's just cross that off there, and we know that p-value is between 0.0001 and 0.001. Now we can find it using R if we want to go ahead and go to our studio, and we're going to do, it's not times 2, degrees of freedom is now 39, and we'll go minus 3.95, so it's 0.00016, it turns out to be. Okay, so we're going to say that we reject the null hypothesis, and we conclude the mean really is less than 75 times. So, as a believer, we should just go to the manufacturer and tell them our findings and see what they do. It's right to expect some form of compensation. Their claim is justified, demonstrably wrong, and it's this kind of thing where lawsuits would tend to come in